Alright guys, so today our objective is moving on to writing rules for geometric sequences. I'm going to go ahead and do it in the style of Cornell notes. So at this moment, you guys can definitely pause the video and just copy this down in your composition book using the Cornell note style. And then when you're ready, push play and I will help you fill in the notes. Alright, so go ahead and pause it. Alright. So geometric sequences. So over the last couple of days, over last week, we talked about arithmetic sequences or arithmetic sequences. Well, today we're moving on to geometric sequence. Geometric sequence is a sequence of terms that have a common ratio between them. In the last section, we talked about arithmetic sequence having a common difference. Well, this time we're having a common ratio. A recursive formula. So since it is a sequence, there's going to be two formulas that we're going to go over today, recursive and explicit. There's going to be some minor changes from the arithmetic or arithmetic to this geometric one. So recursive formula is a formula used to find the next term. And here is the rule, or the recursive rule. I have n has to be greater than 1. A(n) or a sub n is equal to r times the quantity of a sub n minus 1. So this r is going to be your common ratio between terms. And this one, that a sub n is just like in the previous sequence, the arithmetic, that is your previous. So if you want to take a side note here, common ratio is going to be the same thing as the constant multiplier. That's, instead of adding the same number over and over, either it be positive or negative, we're going to be multiplying by some number over and over. We don't really talk about dividing. We can multiply by more than 1, greater than 1, or multiply less than 1 in a fraction form. Okay, so let's move on to the next one. Example 1, find the common ratio, write the recursive formula, and calculate the 5th, 6th, and 7th terms of the sequence. So I have the sequence 3, 6, 12, 24. If you're kind of still stuck in the arithmetic sequence here, you're like, okay, I can get from 3 to 6 by adding 3. And if I'm following the common difference of 3, that should be 9, but that's actually 12. So this one doesn't work. Okay, so let's move on to our next possible sequence. Is instead of the common difference of adding common difference, we're going to be multiplying. So the initial term, this one is going to be a sub 1 is equal to 3. I know I have these nice little boxes here, so if you wanted to, you can pause the video and just copy this down in your notes, and then I'll help you fill in. The common ratio, what is the constant multiplier here? Well, I know that I got to multiply by 2 to get from 3 to 6. Multiply by 2, multiply by 2. So my common ratio here is going to be 2. I'm multiplying by 2 each time instead of adding the same number over and over. I'm multiplying by 2. What is the recursive formula? The recursive formula is going to be a sub n is equal to the common ratio, which is 2, times a sub n minus 1. And there's your recursive. Okay? And if I need to find the 5th, 6th, and 7th term, I already have the 4th term up there, which is 24, so I keep multiplying. So a sub 5 is equal to 48. Multiply that by 2, a sub 6 is equal to 96. And then multiply that by 2, a sub 7 is equal to 192. Because I am multiplying by 2 each time. So again, this would be that r is equal to 2 is the same thing as saying constant multiplier instead of the common ratio. Okay? moving on. Alright, so let's jump right into the explicit form. The explicit form is a form used to find, I'm assuming it's going to be, instead of the next term, the more practical, it's going to be any term of a sequence. And I went ahead and put a red box around the form. So there it is. It's going to be, I'll write it again for you, a sub n is equal to a1, you should know that that's the initial term, multiplied by the common ratio, n minus 1. And that right there, that n minus 1, that is going to be an exponential form. It's going to be n minus 1 to the power of n minus 1. Okay, so this is to the power of n minus 1. So here's an example. The same exact example as the last one. What is the initial term here? It's a sub 1 is equal to 3. The common ratio is going to be multiplying by 2. Explicit form is going to be a sub n is equal to the initial term multiplied by the common ratio, which is 2, n minus 1, to the power of n minus 1. Okay. And let's talk about how we need to find the 12th term. So the 12th term, I'm going to write this out for you. A sub n is equal to 3 times 2. Instead of n minus 1, I'm going to put 12 minus 1. Okay. And then I get a sub n is equal to 3 times 2 to the 11th power. Orders of operations here, this is tricky. I gotta go a sub n is equal to 2 to the 11th power, which is 2048. So it's going to be times 2048. And then a sub n is equal to 2048 times 3, which is equal to 6144. And instead of a sub n, I should write a sub 12 is equal to 6144. Okay, let me change that for you because we are finding the 12th term here. So it's going to be a to a sub 12, not a sub n. And that is my answer. Now, I'm going to go off here to the side where it is what not to do. What not to do. Try not to go a sub 12 is equal to 3 times 2, 12 minus 1, and then you do something like a 12 is equal to 6 to the 11th power. Because you're multiplying 3 times 2 and then doing the exponents. That wouldn't work. Orders of operation wouldn't work because 6 to the 11th power is going to be a really large number. So that does not work. This one is the way to go. That's actually how you would evaluate the explicit form. Okay, I'm going through this pretty quick, so please pause the video, copy down the notes in the example. We will definitely go over this in class. And this right here, this common ratio is the new piece of information with the new explicit and the new recursive formula. Okay, so last example, we're going to find recursive and explicit rules. Considering the following sequence, go ahead and write this down in your notes. Pause the video because there are a couple of examples here. First, I'm going to ask you just to find the rule. You need to decide if it's arithmetic or geometric. So this one has the common difference, D, and this one has a common ratio, which is R. D means I'm going to add over and over. R means I'm going to multiply over and over. Okay, so if that is typically plus 12, 14 plus 12, that should be 26. So right away, this arithmetic does not work. So it has to be geometric. So in order to find R, I just take the second term, or whatever term that's after the previous one. So I'm going to go 14 divided by 2, which is 7. So R is equal to 7, which is actually my next question. I'm going to find the common ratio. R is equal to 14 halves equals 7. You could do it the other way too. 98 divided by 14, that should also equal 7. Okay. Now that I have this, r is equal to 7, it's a geometric sequence. I'm going to multiply by 7 each time. So the recursive is going to be a sub n is equal to, okay, if you don't remember it, look through your notes real quick. I'll scroll back up here. There is my recursive. It is a sub n is equal to r times n minus 1. Okay, so a n minus 1. Okay. Scrolling back up for you one more time. There it is. There's my recursive. So I just take this 7 and go OK. Draw my arrow here. A sub n is equal to 7 times a n minus 1. Basically, I'm telling someone take the previous term and multiply by 7 to get the next one. Okay, so this one's to help me find the next term. Explicit finds any term here, any term. So to find an explicit, a sub n is equal to the initial term or the first term times r n minus 1. Okay, so I just replace a sub n is equal to, the initial term is 2 times 7 n minus 1. Again, my common ratio is 7, so I'm just replacing that 7 with the r, or excuse me, replacing the r with the 7, which is the common ratio. And that is my explicit rule. To find the eighth term, all I have to do is go a sub 8 is equal to 2 times 7, 8 minus 1. A sub 8 is equal to 2 times 7 to the 7th power. A sub 8 is equal to 7 to the 7th power is equal to 2 times 82, 3543. So 823,543. I multiply that by 2. And a sub 8 is actually equal to 1,647,086. And there is my eighth term. Okay, you can quickly tell that my terms get bigger because I'm actually, instead of adding the same number and over, this is actually a nonlinear function. It's going to be a curve graph. It's growing rapidly because it's an exponential graph in this case because it has that exponents. Okay, so just in review here, that's this type of sequence. Instead of adding the same number over and over, we are actually multiplying. That would be geometric. So for geometric sequence, you need a common ratio. And the two forms are there. And please pause the video, take down the Cornell notes, write a summary, and then we will go over in class. Thanks, guys.